Introduction to Projection of Planes. In this video, we are going to learn Introduction to Projection of Planes. Let's see what is meant by plane, orientation of planes. What is meant by plane? A plane is a flat two-dimensional surface with no thickness. A plane is a two-dimensional shape having length and breadth only. Its thickness is always negligible. Example paper. A plane can be made by several lines, and to make a plane we need a minimum of 3 lines such as triangle. And square, rectangle, circle, pentagon, hexagon, etc. also come under planes. Notation for the original plane should be given the lettering as uppercase A, B, C, D, etc. The front view of the plane is designated by lowercase letters with dashes, that is A dash, B dash, C dash, D dash, etc. The top view of the object is designated by lowercase letters without dashes, that is A, B, C, D, and side view is designated with lowercase letters with double dashes. Here are the 4 possible orientations of the surface of a plane with respect to the principal planes. Surface of the plane is parallel to one plane and perpendicular to another. Surface of the plane is perpendicular to both. Surface of the plane is inclined to one plane and perpendicular to another. Surface of the plane is inclined to both principal planes. Surface of the plane parallel to VP and perpendicular to HP. Let us assume a plane which is parallel to VP and perpendicular to HP and designated as ABCD. Draw an XY reference line, say 100 mm. Write above XY line as VP and below XY line as HP. Now let's see which view gives the true shape of the plane. This case, the front view gives the true shape of the surface. Now we can draw the front view above XY line as a square plane with A dash, B dash, C dash and D dash. And the top view appears as a line, so draw a line below the reference line and name it as A, D and B, C. The side view of this plane also appears as a line, so draw a line on the profile plane and name it as A double dash, B double dash and D double dash, C double dash and give necessary dimensions. Let us see a problem on these cases. Case 1. A square ABCD of side 40 mm is parallel and 20 mm above HP, and the side AB is 10 mm in front of VP, and the plane is perpendicular to the VP. Draw the projections. Draw an XY reference line, say 100 mm. Write above the XY line as VP and below XY line as HP. Let's see which gives the true length and start drawing it. In this case, the top view gives the true shape of the surface. Now we can draw the top view below XY line as square and name it as A, B, C and D with 10 mm distance from the XY line. And the front view appears as a line. So draw a line above the reference line with naming A dash, B dash and D dash, C dash at a distance of 20 mm above the reference line. Now let us draw the side view of the problem. Consider an x1, y1 line perpendicular to xy, and these two will intersect at point C. And from top view, draw the construction lines from points AD, BC on the x1, y1 line. And by using compass and C as center, draw arcs until it touches the xy line. From there, extend it upwards vertically. Now extend the line from the front view of the points A dash, B dash and C dash, D dash. From these points, draw a horizontal line until it touches the vertical lines, and it will intersect at A dash, D double dash and B dash, C double dash. This is our required side view. The orthographic projections for this plane surface will be obtained by following the above sequence of operations. Surface of the plane is perpendicular to both principal planes. Here I am considering a hexagonal plane for the problem. A regular hexagon plate of side 30 mm has its surface perpendicular to both HP and VP. Draw its projections when two sides are parallel to HP. Here our assumption of a plane should be parallel to the profile plane. And first we should draw a side view because it gives the true length of the plane. Let us draw a xy line, say 100 mm. Then draw x1y1 line perpendicular and intersect with the xy line. According to the condition, draw the side view as a regular hexagon which is already given in the problem. The construction of the hexagon is: draw B''C" line with 30 mm horizontally. From B', draw a 30 mm line with 60 degrees left side, and from C', draw a 30 mm line with 60 degrees right side. And from B', draw a 30 mm line with 60 degrees right side, and from C', draw a 30 mm line with 60 degrees left side. Keep the endpoints as F', and join all the points. Name it as A', B', C', D', E', and F'. Draw the lines horizontally from A', B', and C', D', E', F' points, and mark the front view as E', F', A', D', and C', B'. Draw a line with 45 degrees down from intersection of two lines, xy and x1y1 lines. Now produce the construction line downwards until they touch the 45-degree line. From there, draw horizontal construction lines individually. Extend the construction line downward from the front view. Extension of the front view and side view lines will intersect and make the top view as A, F, B, E, C, D, and keep the dimensions as much as drawing needs. The orthographic projection of the plane surface obtained by the above sequence of procedure. Surface of the plane is inclined to one plane and perpendicular to another. In this orientation, we have two cases: surface of the plane inclined to HP and perpendicular to the VP, surface of the plane inclined to VP and perpendicular to the HP. Case 1. Surface of the plane inclined to HP and perpendicular to the VP. A regular pentagon of 25 mm side has one side on the ground. Its plane is inclined at 45 degrees to the HP and perpendicular to the VP. Draw its projections. Let us discuss the procedure for a solution. Draw a x1 line, say 100 mm. When the plane is inclined to HP and perpendicular to VP, two steps can be used to solve the problem. Step 1. First, assume that the plane is parallel to HP and perpendicular to VP. Draw the top view as pentagon as per given dimension. Pentagon can be drawn by following method. Now, according to problem, one side is on the HP, that is AE. From end E, draw a line 25 mm with 72 degrees left side and name it the final end D. From the end A, draw a line 25 mm with 72 degrees right side and name it the final end B. Take compass from the point D and B, draw an arc with 25 mm. These two arcs will intersect each other. This point, mark it as C. Now draw the pentagon through these points. Well, our required pentagon is drawn. Name it as A, B, C, D, E. And from the top view, project lines on XY line for the front view as line. Name it as A', B', C', D', E'. Step 2. Tilt and reproduce the front view with the given inclination 45 degrees. Name it as A1', B1', C1', D1', E1'. Draw the light lines downwards. From the top view, draw the light lines right side horizontally. These lines intersect with appropriate points. Identify that point and name it as A1, B1, C1, D1, E1. It is the reduced view of the plane due to its inclination with HP. And keep the dimensions as much as the drawing needs. The orthographic projection of the plane surface obtained by the above sequence of operations. Surface of the plane is inclined to both principal planes. A regular pentagon of 30 mm sides is resting on HP on one of its sides with its surface 45 degrees inclined to HP. Draw its projections when the side in HP makes 30 degrees with VP. This is a complicated case in these of the total problems, and it can be completed in 3 steps. Let us discuss the procedure for a solution. Draw an XY line, say 120 mm. When the plane is inclined to HP and VP, 3 steps can be used to solve the problem. Step 1. First, assume that the plane parallel to HP and perpendicular to VP. Draw the top view as pentagon as per given dimensions. Pentagon can be drawn by following method. Now, according to problem, one side 30 mm on HP, that is AB. From end A, draw a line 30 mm with 72 degrees left side and name it the final end E. From the end B, draw a line 30 mm with 72 degrees right side and name it the final end C. Take compass, form the points E and C, draw an arc with 30 mm. These two will intersect with each other. This point, mark it as D. Now draw the pentagon through these points. Well, our required pentagon is drawn. Name it as A, B, C, D, E. And from the top view, project lines on XY line for the front view as a line. Name it as A', B', C', D', E'. Step 2. Tilt and reproduce the front view with a given inclination 45 degrees. Name it as A1', B1', C1', D1', E1'. Draw the light lines downwards. From the top view, draw the light lines right side horizontally. These lines intersect with appropriate points. Identify that point and name it as A1, B1, C1, D1, E1. It is the reduced view of the plane due to its inclination with HP. Step 3. Now draw a 30 degrees line below the XY line. Keep the pentagon on the 30 degrees line with A1, B1 side. Mark the remaining points C1, D1, E1 as per the reduced top view. From each point, extend the light lines upward and extend the light lines from the front view right side. Identify the appropriate points and join it. Mark the point as A1', B1', C1', D1', E1'. This is our required view when a line is inclined to both the planes. And keep the dimensions as much as the drawing needs. The orthographic projection of the plane surface obtained by above sequence of operations. Auxiliary plane. Planes can be divided into 3 categories. Principal planes. We know that the principal planes are horizontal plane and vertical plane. Profile plane. This plane is perpendicular to HP and VP. Auxiliary planes. Auxiliary inclined plane, it is perpendicular to VP and inclined to HP. Auxiliary vertical plane, it is perpendicular to HP and inclined to VP. Now, let us discuss some of the points regarding the auxiliary plane. What is an auxiliary plane? It is a plane used to show inclined surface true shape, and the direction of sight must be perpendicular to the inclined plane. Draw the projection of a hexagon of 25 mm side, having one of its side in the HP and inclined at 60 degrees to the VP, and its surface making an angle of 45 degrees with HP. Use auxiliary plane method. When the plane is inclined to both planes, this kind of problem it can be solved by 2 methods. These are change of position method and auxiliary plane method. Now let us solve the problem by auxiliary plane method. First, draw an XY line, say 100 mm. Now keep the regular hexagon parallel to HP. We already drew the hexagon in previous problems. The top view comes as a hexagon with side 25 mm with A, B, C, D, E, F. And front view as a line with A', B', C', D', E', F'. Until here, same procedure for both methods. From next step onwards, procedure is going to be different. Now draw an auxiliary inclined plane x1, y1 inclined to 45 degrees xy line from the point A dash B dash. Draw the light lines perpendicular to the x1 y1 from A dash B dash C dash D dash E dash F dash. Then, to draw the auxiliary top view, measure the distance from xy line to each point, like A dash to A, B dash to B, C dash to C, E dash to E, D dash to D, F dash to F, and mark points with appropriate distances above x1 y1 line as A, B, C, D, E, and F, and join these points. This is the auxiliary top view. Then, to draw the auxiliary front view, take an auxiliary vertical plane. This could be drawn 60 degrees one side BA of auxiliary top view as x2 y2. Then project the perpendicular lines to x2 y2 from the points A, B, C, D, E, and F. Mark the points to get an auxiliary front view. Measure the distance below the x1 y1 from each point. Mark the same distances from x2 y2 lines at appropriate points. Join all the A dash, B dash, C dash, D dash, E dash, and F dash. This is our required auxiliary front view. Keep the dimensions as much we need. This is an alternative method for change of position method. This is the way to solve auxiliary method problems.